Great. Well, welcome everybody to the KUKA.Sim Startup and Basic Training webinar. We're very glad that you're all here. Our presenter today is our engineer, Jeff Hong. Your microphones have been muted, so please, if you have any questions, please type them in the chat area. We will have time at the end of today's presentation, and we'll ask the questions in the order that they were received. And if we don't get to your question, I will mark all of them down. We will answer them and get them back to you. So without further ado, Jeff, I will hand it over to you.
Thanks, Sue. All right, hello everyone. Again, my name is Jeff Hong. I've been with KUKA for quite a while now, primarily working with the simulation product. And so if you've had any exposure to KUKA.Sim, then at some point you probably got an email from me or spoke to me regarding, different aspects of our product. As Sue mentioned, if you have any questions, please type them in the chat. And you might also want to add the page number of the slide that you're referencing for your question. That way, if I have to go back to it, I can just quickly find that page for any questions. So it looks like there's a bunch of people coming in still. We'll go ahead and show our definition here for the orange intelligence. This is this circular symbol that you'll see in a lot of our KUKA videos and such. This is just kind of what the philosophy is behind this symbol. And so I'm not going to read it here for you guys, but this is recorded. So if you choose, you can go back and reread this at some point in time in the future. So we're going to just get into it. Now, I know that this was touted as like a basic training. I wouldn't even put it that far as the webinar goes. Primarily what we're trying to do is answer a lot of the very common questions that we get and provide those answers in this webinar and also in a format that you guys can reference in the future if you need to go back and rewatch this, and to just kind of give you some tips and tricks as well. So just starting with some general information about KUKA.Sim, beginning with version 4.0, all the licenses will be sold as floating licenses and as one-year subscriptions. So that means that when you purchase a KUKA.Sim license, you will get that license for 1 year. And then at the end of that year, we don't renew the licenses. What we do is you just buy another license. That way you're not keeping track of all the old licenses. You just get a new license whenever it expires. All of the licenses are floating and they require activation on a license server. And this is just license server software that you would install. Ideally, the license server software should be installed on a network server so that all users can have access to it, but it's not a requirement. So if you are the only person that is going to be using KUKA.Sim, then you can just go ahead and install that license server locally on the same PC that you're going to be using KUKA.Sim on. The license server must be installed for all purchased licenses. Now, as far as trial licenses go, these are just standalone license keys, and they're only good for 30 days. So there's no license server required for the trial licenses. All you're going to do is you're going to get a license key, and you're going to take that key and enter it into KUKA.Sim when you launch it for the first time. And in order to get that license, that trial license, you have to be registered on my.kuka.com, and you can request it through that website. And each registered user is allowed one trial only. Those 30-day trial licenses, they cannot be extended. It's just a 30-day trial. Hopefully in 30 days, you figured out whether KUKA.Sim is the right tool for you, and you will make the decision to purchase the software to continue on with your project. So just starting off from the basics here, a very common question we get is, how do you download the software? Well, like I said, you have to be registered on my.kuka.com. You log in there, and then there's some drop-down menus. You'll navigate to marketplace, software, engineering for robot systems, and simulation. And then on the left, you can click on the product family KUKA.Sim to filter that down to a fewer number of results. Next, you'll click on the KUKA.Sim 4.1. Floating is the F, 1 year, that tile. You click on that, and then you scroll down and you'll see the link to download in the download section. One note about the my.kuka.com registration, you must use an email from a private domain. So Gmail, Yahoo, Hotmail, etc. cannot be used to register a new account. There was an exception made for the videos that you're going to see during this webinar because we wanted to be able to show what a new user would see, and that was the easiest way to create an email address was to make a Gmail account. But in general, it must be from a private domain. So for instance, yourcompany.com, you would have to register under that email, not a Gmail. So here is the example of how you would do that. You go to my.kuka.com, go to marketplace, software, engineering for robot systems, and then simulation series. After you get there, on the left-hand side, you can click on the product family KUKA.Sim to reduce the number of results. Scroll down and go to KUKA.Sim 4.1, and then scroll down some more and you will see the software download. When you click on that, it directly downloads that software as a zip file. You will see that coming up in your downloads folder. And then after that's downloaded, it should show up, and then you would just unzip it and install it like any other software that you would get. Okay. Good. Next, we also have a piece of software called Visual Components Experience, and this is a viewer for the simulations. It allows you to view an animation that's created by KUKA.Sim on any computer that has this Visual Components Experience installed. There is also an option to export the simulation to a 3D PDF. However, that Adobe version has to be a 32-bit version. And now that Adobe has upgraded to 64-bit, a lot of people are less willing to downgrade back to the 32-bit version. So we are recommending to just go to the Visual Components Experience. It is an additional install, but then it allows you to keep your Adobe 64-bit installed. The process is the same as explained previously. However, what you'll do is just go to the download link for the Visual Components Experience instead. And so same workflow here, engineering for robot systems, and then simulation series. We'll scroll down and select KUKA.Sim. And then scroll down to the bottom, and then you'll see the Visual Components Experience 1.6. Okay. Another question we get asked often is, how do you get your KUKA.Sim 4.1 trial license? Again, it's the same workflow. It's in the same location. And so when you go to the marketplace, you're going to get to the same download section. Let me skip ahead here a little bit. Scroll down to KUKA.Sim. And this time, after you go in there, you'll notice at the very top, there is an access trial button. Just click on that, and then it will already recognize your email address, and you should see it in the open dialog. So just click on the continue button from here, and then you will see your product key come up immediately. You will also receive an email from KUKA, which includes this product key. So this is the product key that you will just copy and paste when you start running KUKA.Sim for the first time for your trial license. the email that you'll receive should look something like this. So it will provide you with the product key, and then it will also give you instructions on if you need to download the software if you have not done that yet. Okay, moving on. How do you activate a KUKA.Sim trial license? So this is pretty simple. After you've installed KUKA.Sim, on the welcome screen, you'll just click Next, select the option indicating that you have a standalone product key, and click Next, enter the trial product key, click Next, and then click Finish. So this is how that would look. When you launch KUKA.Sim for the first time, you will see a welcome screen pop up. Just go to the next screen, indicate that you have the standalone product key, and click Next. Enter the product trial license that you received. Click Next, and then at this point, it will go online to the global license server to validate that product key for a trial. And then it will indicate that you have 30 days to use the software. And then once you click Finish, KUKA.Sim will launch. It takes a little bit longer for the first time to launch because once KUKA.Sim is running, it will take some time here to update the catalogs in the e-catalog to make sure that you have the latest components. Okay, how do you access your KUKA.Sim product key? After you've purchased, this is regarding licenses that you have purchased, not the trial licenses. But after you've purchased a license, you can access your product key from the my.kuka.com page. Again, we'll just follow through this video here. Oops, sorry, let me go back here. We'll just follow through the video to show you the process to do that. So from there, you go to Asset Management. Next, go to the Software and Licenses link. And then from here, you should see the licenses listed. And if you click on the drop down and view details, it will give you some further details on that particular license, including the product key. Okay, the last one, as far as installation goes, is installing the license server software. So this license server software is just like any other license server software installation. I do not have a video for this one, but the process is very simple. You go ahead and you launch the executable, go through the welcome screen, agree to the licensing agreement, and confirm all your installation locations and whether or not you want a shortcut option to be added to the screen. And go ahead, click Next, and finish the installation. And then that way, once that's done, your license server will be installed. As I mentioned, the license server would ideally be on a network server so that all the employees in your company are able to access that license and check it out as needed. However, if maybe you don't have a network server that's available, or if you're going to be the only person using that license, you can install a license server locally on your own machine, and then KUKA.Sim would just go ahead and check the license server on the same machine in order to get the license for use. After the license server is installed, you still need to activate that floating license. And so in this case, that license server must have an internet connection to complete the process of activation. If it does not have an internet connection, then there's a different process than what I'm going to show here. It would require you to generate a file and send that file to our simulation team. But this would be the normal way to activate your license. So here you would launch the license server. You would click the add button, enter the product key, and then after the product key is added, you can click the activate button to activate it. So we're going to show briefly what that looks like. Here is the license server software, and you can click the add button, enter the product key. Next, click on add. Select that product key again and click on activate. In the lower left of the window, it shows the status. Currently, it is validating that key with the license server. And you can also notice in the menu bar that the license server is online as far as in the connection section. It does take a little while to get that product key to be validated and activated. Once it is activated, you can select the product key and click on products, and you'll notice that there are, it will indicate how many licenses are available total and whether they are available on the network or commuted as well. So in that section where at the end of that last video, it indicates a couple things. It'll indicate how many licenses you have with that product key. It will indicate how many are being used on the network or how many are available on the network. So when I don't have KUKA.Sim running, it will look like this. One license is we have one license total. It's available on the network, and it's also available to be commuted, which is to be borrowed. When I launch KUKA.Sim, that display changes, and it shows me that I'm using one network license and that there are no licenses available on the network or to be borrowed. And then when I borrow a license, the display changes to indicate that I have only one license, but it's not being used on the network, nor is it available on the network. It is being commuted, and there are no more available. To use the license with KUKA.Sim, you would just go ahead and launch KUKA.Sim, and then on the welcome screen, you would change the selection to my organization is using a network floating license server. Enter the host name or IP address, and then click next. And then when the network license is complete, click finish. Let me go back and show you that process here in the video. So looks like this is the wrong video. This is the same video from before. So don't think I have that one keyed up. But essentially that is the process that I outlined here. Okay. On expert.kuka.com, we have some video tutorials for KUKA.Sim. These are just generic videos that show you how to, say, navigate in KUKA.Sim and how to do some basic things. To get access to those tutorials, you would log into Expert and then type in KUKA.Sim tutorial, and then that will show up for you in the window to watch the tutorials directly from the site. So this shows how that would happen. Searching for a KUKA.Sim tutorial, it should show up as the top search result. So just click there. And then here is a listing of all the different tutorials, like how to import a component or how to import other items, defining tool and base, etc. You can just click the video there and expand it to watch it directly from expert.kuka.com. In this video, they're explaining how you might use the snap function to define the tool center point using a 2-point method. Okay. Moving on, I have a couple tips and tricks I wanted to show you with a live demo today. This has to do with just the user interface and how you can navigate through the user interface, how you would just get to know what that interface is giving you. So the first one is the RSL versus KRL view. I'm going to go ahead and switch to KUKA.Sim here. And I'm just going to open a program here for example. And so when it says RSL versus KRL view, what we're concerned with is how the program is displayed in KUKA.Sim. What you see here is called an RSL format, or like a robot simple language. So you know, we have a point-to-point move here, spline point-to-point. We have a weight move, another spline point-to-point, and output. This is not how it would look in KRL, but this little K button right here will allow you to switch to KRL view. So by clicking this button, it switches it into a KRL view, so it looks like it would show on the teach pendant itself. One other thing that's kind of interesting here is if you select a point, you can also click on this light bulb and select change instruction. And then what it will do is load the button menu that you would normally see on the teach pendant if you were to modify that point. So here you can make whatever changes you normally would make, like change it to continuous and then say Command OK, and then give you a warning here, but then it would also show that that continuous parameter was added. And then just clicking the K again switches you back to the RSL view. Program versus data or DAT file view. So that is the other button that's next to the K is a D, and that D is for data view. When we switch to this view, what it gives you access to is the data file for that program. My main program has 6 points in it. If I switch to the KRL view, you can see the DAT file just like you would on the robot controller, or you could just look at it as a RSL view, which is just showing you basically how many points you have and what the names are. Okay, the next item is the extended program view. And the extended program view refers to this area up here. So when I right click in this area, I can turn off the extended program view. This is how it would normally look when you launch KUKA.Sim for the first time. You do not see all the additional folders that are in the structure. So if you right click here and select extended program view, then you will have access to all the other folders that are in the program structure. And this would, for instance, give you access to the config.dat file. If I go to the config.dat, I can see all the same parameters as you would normally see in the config.dat. And all these, and any other programs as well. Okay, view manipulation. So since KUKA.Sim is a 3D environment, it's just like any other CAD software. You can change your view. At this point, I'm right-clicking and moving my mouse, and that's allowing me to orbit. So change the orbit, looking at it from different angles. If I hold right and left mouse buttons together, that allows me to pan. And then finally, if I scroll my mouse up and down, that allows me to zoom. Another way to zoom is to hold the shift button and right mouse click and drag. So that's an alternative way to zoom if you don't have a scroll wheel for some reason. The fill all button is another way to change the view within KUKA.Sim. If you are working on something very detailed, I'm looking at something here. If I ever want to just show everything in the simulation, I can click this first button, which is the fill all button. And that just zooms out and includes everything in the simulation into the view. The fill selected is the next button down. So that's this button here. So if I select the robot controller and I click on fill selected, it will focus only on the controller. If I go back to fill all, I can select the robot, fill selected, or select the cube, fill selected, and it will focus in on the cube. The next button is the headlight button. What this does, it just changes the look of the simulation. It basically is as if you had headlights on directly in front of you and you were to turn those lights on. So if I zoom in here, if you look at the shadows of that robot, when I turn the lights on, you can see it brightens up. When I turn the lights off, it just goes more to like a natural lighting. So this would be as if I had the headlights on. You can see it just kind of brightens things up. If I turn the headlights off, it goes back to normal shading. Next is the render mode button, which is this button here. You have many different ways that you can visualize graphics in KUKA.Sim. So if I go to wireframe, you'll notice everything just looks like just the wires, lines from the tessellated objects. I can go to faced only with edges shaded, X-ray. So these are just different view modes that you can turn on. Obviously, it's personal preference which one you might want to use. One button that I missed on my list is the orthographic button. So this button is just like any other orthographic button in CAD software. If I turn it on, it turns on the perspective view. So it makes it look like the things that are closer to me are bigger than the things that are farther away from me. So if I turn it off, you can see how the scale dramatically changes versus if I turn it on, it would look more like it does in real life. Frame visibility. So frame visibility is this button here. You can turn the frame visibility on and off by just clicking on the icon itself. So now they're off. If I click the button, it turns it on. You can see this base data here showed up because currently I have robot bases selected. When I click on this drop down, I can turn on different frames to make visible or invisible. And then I can click on the icon itself to turn them all on or off. Position frame display options. That's just similar to the frame visibility. We can have the different positions and turn them on or off. So for instance, right now, I have, you can see my points are kind of overlapped on here. But by turning them on or off, I can use this button to change that. And then view editor and view selector. That is wrapped up in this last one. So what this is referring to is the view of your current screen. I don't have any views right now saved, but I can add a view by just clicking this plus button. So now I've created a view of this this view right here in this position and orientation. I can move the move the things around, move my camera view, and create a new view if I like. So now I have two views, and if I click on one view versus the next, I can now quickly switch back and forth between views, or however many views I have. This can be really helpful if you're always going back to the same location, you're always working at the same on the same thing and switching between two different locations. And also these views can be used later on when you export an animation or a 3D PDF as well. You can actually have the simulation switch views as it's running the program. Okay. A couple more tips and tricks here. When you're zooming in on small objects, sometimes what happens is the graphics area appears to cut into the geometry, and you're not able to achieve the desired view that you want. And so what you can do here is right-click and on the area of interest and select Center in 3D View, and then the spot clicked will be centered in the view. I'm just going to demonstrate this for you rather than run these videos. But let's say, for instance, that I want to zoom in on this robot and I want to zoom in this area here. So as I zoom in, actually, it looks like it might be centered on that. So for example, if I center here, if I center here and I want to zoom in on the robot wrist, as I zoom in, you'll notice the wrist gets clipped. So I can't zoom in any farther. It looks like it's actually disappearing on me. That's because I'm actually centered over here on my view. So what I can do is I can right click where I want to zoom. Let's say I want to zoom right here, right click on that and center in 3D view. Now when I zoom in, you can see I can zoom right in on that 5 right there. And when I orbit, it's going to stay right there as the center of my view. Whether I'm zoomed in very close or whether I'm zoomed far away, that same spot will be in the center of my view. So likewise, I can right click over here, center in 3D view. Now that A is going to be the center of my view. And no matter what I do, I can zoom in very, very close to that A or zoom in, zoom out far from that. A shortcut to doing that is the control right click. So at this point, if I zoom out and I do a control right click, so holding control, I right click right there, it will cause that point to become the center of my 3D view. So you don't have to do the right click and select, you can just control right click, and now I have changed the center of my 3D view to where I clicked. Okay, snap tool. The snap tool, what it does is it helps you to move the origin of the selected object to a geometric feature of another object. The snap mode allows the selection of the target location with 1, 2, or 3 geometric references. In the case of 2-point selection, it will choose the midpoint of those two. And in the case of a 3-point selection, it will choose the center of the arc that is created by those 3 points. The snap settings define whether the position, orientation, or both are changed when snapped. And finally, the snap type at the bottom is just a filter to make the target geometry easier to select. So let's just watch a demonstration of that. I select the cone here, and then when I click on the move button, you'll notice that the part origin is displayed. And I can click on the handles and move those around like I normally would, or I can click on the snap button. And so now you can see that I have a 1-point snap and I'm setting position and orientation. So it's going to put the orientation of the object to be normal to the surface. And it's also going to move the position to exactly where I click. If I activate snap again and I change the settings so that I am just going to go to the center of the surface that I select, then it snaps right to the middle of that surface. It doesn't move all around, it just goes right to the center. And then we'll go ahead and snap one more time. And I can change the snap type to edge. So now it's only going to allow me to click on the edges of the geometry. It will not allow me to click on the faces of that box. We'll go one more time. And now I'm going to change it so that instead of doing the edge, I'm snapping on face. So now it's, again, just like before, allowing me to snap wherever, but it's not allowing me to click on the edge. Next, what we can do is snap with position only. So I'm unchecking the set orientation and I'm allowing edge and face. So now it's going to maintain the same orientation regardless of what face or edge I select. Again, we'll change the settings one more time. So now I'm going to do orientation, but not position. So now the position of the cone will stay where it is, but I can change the orientation of the cone. Next, I'll show how to do a midpoint snap. So it's going to basically take the two snap locations that I chose, and it's going to snap to the middle. So if I choose the lower right corner and the upper left corner, it will choose the midpoint between those. Doing it again, I can choose the far corner and that lower or the center corner there, and it does the midpoint, or the far corner down at the bottom, and then the complete opposite corner, and it will snap right to the center of that cube. Okay. So you can definitely use the snap tool to help improve your precision when you're creating your layouts. The align tool is very similar, but the align tool moves the object from the first geometry reference, which is typically part of that object, to another geometry reference of another object. It's different because the snap always uses the origin of the object as its first reference point, whereas the align tool can use anything. The align settings control how the selected object will move, just like the snap. And set position causes the selected object to move such that the exact point clicked is moved to the exact target location. So that is the set position. Set projected position causes the selected object to move such that the alignment is satisfied with the fewest degrees of freedom changed. And set orientation allows orientation to be changed. So I have a couple videos here to show that. So in this first one, I click on the box, activate the align tool, and then set up my settings. So I'm going to set projected position, set orientation, and use edges and faces. And I can click on the first edge of the green box and click on the first edge of the orange. And now those two edges are aligned. Then click on the second edge of the green box and the second edge of the orange. And now those two edges are also aligned, maintaining that first alignment. Now, if I just move this box out of the way, we can try another scenario. So activate the align tool. And I selected the center of the face and the face of the orange. Now those two faces are aligned. Selecting the left faces of both, now those two are aligned. You can see that they're directly above each other. And now I can select the bottom of the green box and the top of the orange. And now all three are aligned. Two different ways to get to the same result. Okay, and then this video shows the difference between the set position versus set projected. So now we're using set position. So I'm just using set position and using the edge and face. If I click on the point, the corner of the box, it will now move the corner of that box to the exact position where I click. So these are functions that you're just going to have to play with to get the hang of, but you'll notice that I can move that corner to any point that I click on with the set position. Okay. How to define the tool data and base data. So I'm going to just walk through this one briefly here with you. First, we're going to just attach this tool. This is a standard gripper that's in KUKA.Sim. And using the PNP feature, I can go ahead and grab that tool and then move it closer to the robot, and it should snap right on there. After I snap the tool on, I can click on the program tab and then click on the robot to access the jog tab. Next, I will select the tool data that I want and click on the gear to activate the tool data definition. And now you'll see the handles. I can just drag the tool data by using these jog handles, just like you would position anything else in KUKA.Sim. If I want to put that precisely in the center of that cup, I can also snap, just like the snap function we already demonstrated, and snap directly to the center of that cup. If I switch the coordinate system display, it will show you the triad in the tool orientation. So now if I change the orientation, it will reflect that the Z is now pointing out of that cup. Next, I can select a different tool data if I want. And then using the snap function, I can snap to the center of that grid pattern. So I can hold shift and select the center of this first cup. And then as my second reference point for the 2-point snap, I can hold shift and select the center of the second cup. And then you'll notice that the tool data is now defined in the middle of that 10-cup gripper. Again, I can rotate my orientation by 90 degrees so that the Z value is pointing normal to the face of the cups. That's it. Defining the base data is the same as defining the tool data. It's just slightly, it's just using the base data instead, selecting the gear next to the base data instead. Okay, I have a couple more. We're getting close to our 45 minutes mark here. So let's see if I can just go through these fairly quickly. This is discussing how to detect a part for picking. So what KUKA.Sim does is that there's a detection volume that is attached to each tool data. And that detection volume is used to determine whether or not there's an object available to be picked. KUKA.Sim will only recognize an object if its surface intersects the detection volume, and there's no tool required in order to pick an object. So in this first image here, my detection volume is on the inside of this box. So there's no surface cutting through this detection volume. And so because of that, this object is not detected. If the detection volume was moved so that the top surface of this box intersected the detection volume, then KUKA.Sim will recognize that, hey, there's an object here. If the output is turned on, then that's the object that I will pick. So in order to pick an object, you have to move the robot so that the detection volume intersects the object to be picked. Then you have to change the output that corresponds to that detection volume from false to true. So for tool data 1, you would turn on output 1. Tool data 2 is output 2, etc. An important note, the output must transition from false to true to grasp an object. If the output is already true and the output is set to true again, then the object will not be grasped. So here is a video showing this exact same thing. You can turn on the display messages so you can see what is actually happening when the when the outputs are fired. And you'll notice if you go to the signal actions that output 1 is set to be grasped or released based on true or false, and the detection volume size is specified by default to be 50 millimeters cubed. So when we run the simulation, you'll notice that the robot will move down and the object is detected, so it picks the object. The robot puts it back down and moves so that the detection volume is inside the object, and you'll notice that it did not pick that object. Going back to the display here, you'll see that the first time it actually tried to grasp the object, it said that it was okay. Grasp component is box. And then the release action was okay, released component box to the world container. However, the next time we went to grasp again, it indicates that no component was detected to grasp. So we have to make sure that the detection volume intersects the surface of what you want to pick. Also, you can change multiple parameters in multiple statements at once. So if I click, let's say, multiple move positions or multiple wait statements, I can change all of them at the same time with the same value. The properties dialog will show which properties are the same and which ones are different. If the statements have no common properties, only the number of objects selected will be displayed, and changes to the properties will affect all selected statements. Here's an example of that. So I'll just run the program here so you can see what the robot does. It moves to a position, waits for a second, moves to a couple more, waits, and returns home. So now what I can do is click the timer and hold Control and click the other timer. And you'll see now 2 objects were selected, and I can change both timer values from timer 1 to timer 5. Or I can select output 7 and output 7 with the Control key, and I can change both of the output values and use output 1 instead. Likewise, I can do the same with the wait statements. By selecting both using Control, I can change the waiting time to be 2.5 seconds. And lastly, I can select multiple move statements, and it will allow me to make changes to that as well. But at this point, I want to highlight something very quick here. You'll notice that there are some values that show some fields that show values in them, and some that indicate that there are multiple values. So for instance, in this motion here, it says multiple values because the first one I selected was a linear move and the second one was a point to point. If I changed that, then it would set all of the selected statements to have the same value that I change it to. In this video here, I'm just showing you that there are some that have multiple values and others that do not. And I'm turning the blending off. So now you can see the continuous was removed from both of those statements. And so when we run that program again, you can see the difference in the program. The timer values have increased. I was not moving continuously on those 2 points. Okay, so I think at this time, Sue, I'm going to go ahead and end my presentation here. I think I had a couple more, but I want to make sure I address any questions that have come up at this time.
Yep, we have some questions. First one is from Eric. What OS is supported for the license server?
The license server can be Windows 10, so for a regular PC. It's also supported on any of the enterprise servers. I would have to, if he can email us which server he has, I can confirm it, but I don't think I have a comprehensive list.
Okay. Next question, Hugh asked, can step files of an entire robot cell be imported?
Yes. Actually, KUKA.Sim does a really good job at importing in CAD data. Let me switch over here to KUKA.Sim just to show you from the Home tab, we can import geometry, and we can support just about any CAD software format that you can think of. Most of it's solid data that we're importing, even though after it's imported, it becomes tessellated surface data, but it does import quite a few different types of data. This is a spot gun that I had available here, and I'll just import this quickly just to show you what that does. But we can import a whole cell. Then after you import the cell, you would have to potentially break it up in order to change colors of things or whatnot. Or another thing that you can do is change the how do I say this? You can import certain pieces and then reassemble them inside of KUKA.Sim, and then that will help to make it more manageable in KUKA.Sim. But in this case, here's the spot gun that I just imported. And it actually does a really good job with the import. It's much better than the previous versions. Any other questions?
Yep. Can we import a WV project into KUKA.Sim?
WV, I'm wondering if that stands for work visual. Currently that is not supported. In a future version, we will support that, and in the plans for KUKA.Sim and work visual is that those two pieces of software will actually be merged together into one. But that's not expected to happen until, I believe, KUKA System Software version 9. So probably not for, I would say, over a year before that's going to happen. Currently, what we can do is if you create a project in KUKA.Sim, you can export that project as a work visual project. You just cannot import one yet.
Okay, next question. How would you connect KUKA.Sim to Office Light and be able to jog from Office Light and see the robot move into KUKA.Sim?
Yeah, so currently the current release of Office Light is using the Hyper-V image. And so that's we have separate instructions on how to do that, how to launch Office Light and license it and that kind of thing. But essentially what you would do is after you get Office Light running, you would go ahead and I don't have Office Light running right now, but I can show you here from the program tab. You can click on this gear here and then change this to be controller. And then from here, you would click on this button and then find the Office Light controller that you want to connect to. And then after you select that, this connection should change, this status should change to be connected. And then from there, depending on what you have set up, like for instance, if you had synchronizing and go here, and you had Office Lights set up with the T1 mode, then you should be able to jog Office Light and see the robot moving.
Okay, 2 more questions. Can tool or base data frames be pulled in from a config.dat file loaded into the virtual controller?
It's not as straightforward as that, but what you could do is, because I have access to the config.dat within KUKA.Sim, you can just copy it from your config.dat. So for instance, here's config.dat here. If you just expand this and scroll down to your tool data here, load data, here's base data, here's your tool data. You could take your tool data and write it. Actually, what you would have to do, because this config.dat is actually generated from KUKA.Sim, so you would have to take your tool data, like for instance, let's take these tool data here. Let's say I copied that from my my existing tool data. Then I can go into my main program, and then I could paste it here. Let's paste it at the top. I have to be in KRL mode here, so let's paste it to the top. There we go. So I just pasted in the tool data. These tool data here, I pasted in. Actually, this is supposed to be part of it. So you could copy the tool data and paste it into your program, and then that way, when you execute the program, then the tool data will be updated.
Okay. All right, we still have a little bit of time. There's still 2 more questions. What are the options for simulating the pendant with Office Light and pairing it with KUKA.Sim? How does the licensing/pairing process work?
Office Light is the pendant, and so what we described earlier would be the same. You would basically use this connection here in KUKA.Sim, connect to the controller, and then you can jog from Office Light. Office Light requires a different and separate license than KUKA.Sim, and so that would be a separate purchase, and you would have to, after you get both pieces of software licensed and running, then you can make the connection.
Okay, and last question. Some of the robot models are not listed in the catalog. For example, KR6 R700-2. Can it be downloaded somewhere?
So all the robot models that are valid for that version of KUKA.Sim are already in the catalog. Can you repeat what that model was again, Sue?
The KR6 R700-2.
Okay, so that would be a small robot, and here's the Agilus-2 series, KR6 R700-2. Here's the ceiling. Here it is. So KR6 R700-2. So it should be in there. You can also, if you're looking for a particular model, if you click on this folder here, you can type in a search term like R700, and then all those robots should show up. I wonder if it's case sensitive, R700. Let's try one more time. What if I select all models? There we go. So from all models, I typed in R700 and it showed me all the R700 robots that are available. Okay.
All right, and we are at the end of our time, right on time. I want to thank everybody for attending on behalf of KUKA Robotics. We really appreciate it. And a link to this recording will be sent out via email later this week. So thank you very much. Have a great day, everyone.
Thank you.
Industrial intelligence.